And welcome to Ivory Egg presentation at Canix UK Building Tech Day. Here we want to focus on project support and provide you some complexity in Canix project. By the way, my name is Amir. I'm a Canix tutor and I'm from technical and sales department at Ivory Egg. Thanks for your attention. I hope this presentation works for you well. Why smart building projects become difficult? Is it because of the different functions in Canix, or is it because of integration of HVAC systems, or connect the Canix as a field and control layer to the BMS, or using the different gateway and communication between the Canix and other protocols like Modbus, DALI, SNMP, and so on. Support matters because every interface has both a technical and commercial boundary. So we want to talk about why it is complex and how we can overcome it. Of course, you need the project support. Look at this BMS platform. So in BMS platform, we do not only deal with Canix, we deal with BACnet, Modbus, OPC, SNMP, and other protocols. We deal with, if we are in the hotel, we deal with the hotel management software like Fidelio, Opera. We deal with the access control platform from the different manufacturers. We should connect to the universal I/O port, I/O modules, like the ones based on IP. We should communicate with other applications through the API. We could communicate with the hardware gateway. We have like DALI, we have MBus for the metering, DALI for the lighting and ocean for the wireless energy harvesting, DMX for the lighting, and so on. We should connect to the IoT world, MQTT. We should connect to the web visualization and redundant servers, and so on. So in BMS platform, we utilize whole of the building or whole of the city in one platform, one workstation, and this is hard. It's not easy. It needs the very precise design, programming, and commissioning. It takes much more time rather than the simple home automation projects. We should be prepared for that and get the right support. Open standard integration is choosing the right layer. So Canix is strong at the field and room level. BMS protocol often sit above it. So you can consider, for example, the protocol BACnet in the supervisory level and the Canix in a control and field level. So the question here is, what information needs to move between layers, comment, status, alarm, or trend? We should be prepared for that during the design and programming. So look at this BMS topology. You can see here Canix is located in the control and field layer. Field layer is the layer that we communicate with the physical layer of the building. Some person touched the button. This sensor is going to detect the movement. This actuator is close and open the circuit. And all of them is going to the controller. In the controller, the data is manipulated locally. But the above of the controller is going to the supervisory level. So this is some things that make the project a bit hard. So another thing is HVAC integration. This makes your project also complex. Why? Because we have different type of the HVAC in rooms and in plant rooms. If we are in rooms, what are we going to control? Is it heating, underfloor heating, radiator, fan coil? Which type of the fan coil we want to control? Is it 3-speed fan or 0 to 10 volt fan? When we are going to the plant room, is it the condensing boiler coming with the a specific protocol output, or we should design and from the beginning locate the sensor and actuator to control and monitor it. So the feedback, the fail-safe planning, very important. We consider it in an advanced course. So during the design phase, we think about what's happening if some part of the project is going down, some devices is not working. So we should be prepared for that and hand over. So point list, sequence, set point, alarm, and test evidence. Simple rule. Do not integrate HVAC until the required sequence is written down. Yes, this point is going to be considered in the plant room. So when we talk about HVAC, in plant room, we talk about the complex topology. For example, you can see the chiller schematic in these pictures. We want to control it. We should have the right sequence of control. For example, start the pump, prove the flow by the sensor, start the chiller, control temperature by the sensor, sequence chiller, monitor energy, generate alarms, and safe shutdown. We should be prepared for that in the controller. In this picture, you can see the primary controller and I/O card next to it. Or for the air handling unit, very popular in the building automation. So in the plant room, we should provide the sequence control of the air handling unit. Enable air handling unit, check safety interlocks, all the interlocks. Start fan, prove airflow, everything is coming from the sensors and so on. Control temperature, control ventilation using carbon dioxide, monitor filters, alarms, and safe shutdown. We should be prepared for that in the programming, for the pump and for the exhaust fan and so on. So HVAC control is another complex part of the control in our systems. The other one is gateway. We want to connect the different protocol in one platform. These days is very popular. So we want to have one workstation to communicate with the protocol, like DALI to control the light, like Modbus to control the meter, like BACnet to control the plant room, and so on. So gateway is something very important. To select the right gateway, map it in a right way, and commissioning to fulfill the requirements. So gateway, it may be hardware gateway. In some points, we have the software gateway. When we talk about gateway, also we can talk about gateway to AC units. Nowadays, we have in HVAC, we have the different type of the AC units from different manufacturers, from Daikin, LG, and so on. We should consider that should we control the indoor unit or outdoor unit? Check the compatibility and then order the gateway. And during the commissioning, make sure that everything is work in a right way, because you're going to, for example, one simple example is you're going to control the AC unit with your KNX keypad through the gateway. Here we do not have the actuator, we have the gateway. So you should make the link in ETS between the object from your gateway and KNX thermostatic keypad. Then the gateway is communicate with the AC unit to, for example, in a closed loop control the temperature in a room. So the right selection, making sure about the compatibility, and right programming is the key to provide the final projects working. Yeah, this is not easy. It's something challengeable. So another complexity is somewhere you mix different functions together. For example, mix lighting and shading to control, mix lighting and occupancy to control, mix lighting, occupancy and shading, and many others. A good smart building feels simple to the user because the technical details have been solved. Very important. The user only deal with one simple keypad on a wall. That's it. But in the background, everything should work precisely. So you need to design very detailed and program in a way that the user is not affected by the very hard or complex systems. When we talk about lighting and occupancy, what it means? It means, for example, the scenario when the users is in the room, the light is going to reach the set point of the light according to the constant light control. When they leave the room, the light is going to be down, even when the occupancy is not provided. And of course, during the time that the inspection is happening, the minimum light is switched on to show the wave. So here we need to provide a constant light control. We need the light sensors plus closed loop controller inside of it. We need a dimmer or DALI to dim down and up the lights. We need the occupancy sensors. Nowadays, the occupancy sensors coming with light control options. Also, we need the time schedule to let the system know what's happening during the working hours and what's happening during the night. You see, the user face the very easy systems, but behind these systems, there is a strong logic. Or shading and lighting. For example, you want to use the natural light, outside natural light, to minimize the inside light, artificial light, to save energy. Provide a constant light control. Of course, you should avoid the glare and different window direction has a different angle of the sun, a natural light to the rooms. So you should calculate everything. Nowadays, these information is coming from this. It should be simulated before your project is done, and in the software is simulated and provided for the systems, the key parameter. So when you do such a configuration, the behind it is complex, but the user only see the very simple actions. So this is the strength of the BMS engineer. So that I want to talk about the troubleshooting workflow. So before this, we talk about some complexity in HVAC, gateway, complexity of the BMS, utilization of different protocols and so on, and also the combining of the different functions. The troubleshooting workflow is to confirm the error, check the physical layer, check the device status, check the ETS objects, check the gateway mapping, test and documents. In my opinion, so for your ETS project, you can do the check through your ETS online with the group address check, and also if you have the BACnet, you can do you can check your network and so on. So during the design phase, you should be prepared for the right interfaces and so on to connect to the systems. Then later on, during the troubleshooting, because your project is clear, everything is in order, the interface is connected, and then you can do the troubleshooting very well. The point is, do not start by changing the parameter if you have a problem. First, prove where is the problem. Maybe your problem is because of the physical layer. Maybe the problem is because of some fault with your device. It is not only the parameter. So first you should find out where is the error exactly. We can say a project is not finished until someone else can support it. Again, we emphasize on the transparency of the project. The project should provide it with function list, point list, test record, and support pack. This is very important. Maintainability is a design choice. Open standard help, but only when the system is clear documented. Again, emphasize on documentation and transparency of the project. So in ETS, we should have the readable ETS. Readable names, topology, group addresses, notes, make future work easier. Spare capacity. So when you do the design, you should have the spare for the outputs and inputs and so on. Manufacturer supports. You should use some products that the manufacturers are responsible for that products. Very important. You do not install the KNX or BMS products for next 2 years, 10 years. We are going to install it for whole of the, for at least more than 10 years. And maybe for the building life. So the point is you should choose some manufacturers that is reliable, not some manufacturers that does not take care about their products. So the best integration is the one the next engineer can understand. So how Ivory Egg supports project delivery? We are here with you before the order to product selection, compatibility check, design, and provide you the right design. We are here before you go to the site with our official training and special training. We are here during the site. We help you if you have problems, and after the handover, we help you with the warranty and so on. Ivory Egg helps professional specify, combine, deliver, and support open startup building technology with more confidence. So now I would like you to think about these questions and let me know your idea. Where do integration projects usually become unclear for you? When we talk about integration, what information should supplier receive before quoting? When you want to provide a quotation, what information you think we need? What should a good support request include? If you want the best support from us, what is your requirements? Thank you very much for your time. I hope this presentation helps you, and I'm waiting for your questions. Thanks.